In this video, we're going to observe the catalyzed decomposition of hydrogen peroxide. Hydrogen peroxide is H2O2. We're going to compare a 30% solution with a 3% solution and compare their reaction times, which we'll measure right here. We're going to catalyze the reaction because this reaction is very slow. If you have hydrogen peroxide in your bathroom or your first aid kit somewhere, it decomposes very, very slowly. We're going to get it to decompose very quickly. So we have 10 milliliters here of a 30%. This is very concentrated, 10 times more concentrated than what you buy in the store. And this is 3%, which you would buy in the store, also 10 milliliters. We're going to put each of these 10 milliliters into a test tube. And we are going to add the catalyst, which is MnO2, which is manganese dioxide. It's a black solid. Okay, and then we'll just kind of qualitatively observe, and then we will test the gas out with a splint test. So we have a splint, we have a lit candle right here, and we'll test the gas to see what gas it is. So we have just a very small amount of manganese dioxide on each of these scupulas. I'm going to put them in at the same time, and then I'm going to start our timer. So actually, let me just start it real quick, and then we'll put it in. Also, while that's going, I should have taken the temperature, but they are pretty much at room temperature. So here's room temperature, 22.4. And after I do a splint test, we'll take a temperature again. So let's do a splint test. You can see which one is reacting much faster than the other. So with this splint test, you blow it out. It's a glowing splint. Put it in. This one's reacting so much that there's too much moisture, so we'll try the one on the right. There we go. So the one on the right, relit, that tells you that oxygen is a product of this reaction. Again, the one on the left is so vigorous of a reaction that it puts out the flame because there's so much moisture coming out. You can guess what's happening to the temperature, but we'll do a quick look on that. So if I hold this LabQuest right here, and we take a look, let's do the one on the right just to keep ourselves out of danger. You can see the temperature going up from room temperature. And if I go to the one on the left, which is a little more vigorous, we will definitely see a much, much higher temperature. So it's a very, very big temperature change. Okay, so you could qualitatively see the difference between a 30% and a 3% reaction. And what you would do is time both reactions, the one on the left and the one on the right. You would probably guess that the one that's going to end first is the one that's the quicker reaction and more vigorous. However, remember this is a 30% and this is a 3%. So this one has 10 times more to react than that one. So what you would do is you would simply time these and compare the reaction times, and the data is given to you in your lab, and from there you can do all of your calculations.